So my dear students, again in this particular video, you guys are going to get some 10 concepts. That means 40 marks in just 5 to 10 minutes for sure. So watch this particular video till the end. The first question, which is frequently asked in your NEET examination, you'll be asked, Lyman series falls into which region? Balmer series falls into which region? Paschen series into which? Bracket series into which? And Fund series into which? My dear students, you just have to remember one thing. UVIII, right? Lyman series falls in ultraviolet. Balmer series falls in visible. Paschen series, infrared. Bracket series, infra. Fund series, infra. This is a complete memory-based question, which is frequently asked when it comes to your NEET examination, my dear students. 2 years back, the question was asked, Balmer series falls in which region? The answer was visible. Now, anything can be asked from this particular table. It's a simple question, right? You are not supposed to use any pen and paper for this. You just need to remember this particular table. This was your question number 1. Question number 2. What is that? In most of the questions, you'll be asked what? You'll be given with either molality and you'll be supposed to calculate mole fraction, or you'll be given with mole fraction and you're supposed to calculate molality. There is one direct result which I'm giving you, my dear students. Remember that. Molality is equal to mole fraction of solute multiplied by 1000 divided by 1 minus mole fraction of solute, molar mass of solvent. Okay. For example, the question is calculate the mole fraction of solute in 1 molar NaCl aqueous solution. This is the question. You are not supposed to use any brain in this question. Just remember the formula and use that. I'm given with the molality of the solution as 1. Since I'm using aqueous solution, so solvent is water. Molar mass of solvent is 18. So use the result which I mentioned over here. And after solving this particular result, you can easily get the mole fraction of solute, which comes out to be 0.017 over here. Now, question can be asked in the reverse manner as well. In the question, mole fraction can be given, molality can be calculated, right? That can be one more question framed from this particular result, which is very, very, very important. Okay. Moving on to concept number 3. Again, one question in which molality will be given, molarity is to be calculated, or molarity is given, molality is to be calculated. Again, one direct result I'm giving you. Please and please remember this result. Molality is equal to 1000 multiplied by molarity divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. For example, this is the question. Calculate the molality of 1 molar. So molarity is 1. NaOH aqueous solution. Solute is NaOH, whose density is 1 gram per ml. So my dear students, just use the result, put the values and get the molality of the solution. So no need to use your brain again. Just remember this direct result. It's going to ease out a lot of things when it comes to the calculations. Moving on to one more thing. Again, a frequently asked question. How do we calculate equivalent mass of acids? My dear students, equivalent mass, is nothing but molar mass divided by N factor. And in case of acids, what is N factor? N factor is basically basicity. In case of acids, N factor is basicity of the acid. What is basicity? Number of H positives acid donates. Number of H positives acid donates. In this particular reaction, have a look. How many hydrogens do you see here? 2 hydrogens. Since H2SO4 is getting converted into NaHSO4, how many hydrogens do you see here? 1 hydrogen. So that means when H2SO4 has got converted into NaHSO4, how many hydrogens it has lost? So I would say earlier it had 2 hydrogens. Now it just has 1 hydrogen. So it has lost 1 hydrogen. Number of H positives an acid loses is basically its N factor. So N factor of H2SO4 here in this particular reaction is 1. Similarly, here you had 2 hydrogens. It got converted into Na2SO4, 0 hydrogens. So I would say H2SO4 has lost both the hydrogens while getting converted into Na2SO4. So its N factor here is going to be 2. So if you got the N factors of the acids, you can easily calculate their equivalent masses. How exactly? Molar masses divided by the respective N factors. As simple as that. Again, frequently asked question, which I've given you over here. My dear students, there are some very, very, very important reactions of KMnO4 and K2Cr2O7 in acidic medium. Remember, KMnO4 as well as K2Cr2O7 in acidic medium converts Fe di positive into Fe tri positive, I negative into I2, H2O2 into O2, oxalate ion into carbon dioxide, Sn di positive into Sn plus 4, H2S into sulfur. Anything can be asked out of this particular chart over here as well, right? Perfect. And both KMnO4 as well as K2Cr2O7 in acidic medium does all these things. Perfect. Remember this particular stuff, my dear students. And the PDF of this session I'll be sharing on my Telegram. Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel, wherein I shall be sharing the PDF of this particular session as well. Okay. One more frequently asked question, that is balancing in acidic medium. How do we balance the reactions in acidic medium? My dear students, one simple technique I'm telling you. First of all, get the n factor of MnO4 negative, that's 5. N factor of Fe di positive, that's 1. Crisscross these n factors, make this 1 as the coefficient here, make this 5 as the coefficient here. After crisscrossing, balance all the atoms except hydrogen, oxygen. So 1 manganese, 5 iron, 5 iron. Now, balance oxygen with the help of water molecules. You have 4 oxygen on this side, so add 4 water molecules on this side. Now you have 8 hydrogens on this side, so add 8 H positives on this side. The reaction is balanced. You are not supposed to check it again, right? The reaction is balanced now. This is one more short question which is frequently asked. My dear students, one more theoretical question. Have an eye on this particular question as well. Since you know, if Gibbs free energy is kept as the criteria for spontaneity, then for the process to be spontaneous, delta G for the system at constant pressure temperature. Delta G for the system at constant pressure temperature should be negative, then only we say the process spontaneous. But if entropy is the only criteria for spontaneity, then remember, for any process to be spontaneous, delta S total has to be greater than 0. What is delta S total? It is delta S system plus delta S surrounding. This particular term has to be greater than 0. Then only we can say the process is spontaneous if entropy is the only criteria for the spontaneity. Perfect. So remember this particular point as well. This is the criteria of spontaneity if entropy is kept, and this is the criteria of spontaneity if Gibbs free energy is kept. That's all. Similarly, one more frequently asked question. How do you calculate enthalpy of reaction from the enthalpy of formations? My dear students, imagine this is your balanced chemical equation. Remember, enthalpy of the reaction is always equal to enthalpy of formation of products minus enthalpy of formation of reactants. As you can see, I've mentioned N3 multiplied by enthalpy of formation of C plus N4 multiplied by enthalpy of formation of D. This is your enthalpy of formation of products minus enthalpy of formation of reactants, N1 into enthalpy of formation of A, N2 into enthalpy of formation of B. For example, you have got a question here. This is a reaction. I'm given with the enthalpies of formations of all reactants products. You are just supposed to calculate enthalpy of reaction. You can let me know its answer in the comment section of this particular video by just following this particular equation. That's all. Now, my dear students, moving on to the next one. This is one more important thing. When the salt of weak acid and weak base, undergoes hydrolysis, how do we calculate pH at that point of time? This is the formula, my dear students. pH is equal to 7 plus half of P of Ka minus P of Kb. For example, this is your salt, CH3CONH4. Basically, this is CH3CO negative, NH4 positive. I would say CH3CO negative has come from CH3COH and NH4 positive has come from NH4OH. Since this is a weak acid and this is a weak base, so I would say this is the salt of weak acid and weak base. And when salt of weak acid, weak base undergoes hydrolysis, how do you calculate pH? pH is going to be calculated with this formula. So as per the question, pKa as well as pKb is given. So you can just use the result. pH is equal to 7 plus half of P of Ka minus P of Kb. Solve this equation and get the value of pH. That's all. Now, my dear students, there is one more thing which is frequently asked. Which of the following will show DD transitions? My dear students, remember one thing. Whenever you see the unpaired electrons, wherever you see the unpaired electrons with the central atom, wherever you see the unpaired electrons with the central ion, right? At that time, DD transitions are going to happen. Since manganese here is in +7 oxidation state, that means manganese does not have any unpaired electron. Your manganese here is in +6 oxidation state, so manganese has got one unpaired electron. Chromium here is in +6 oxidation state, so chromium does not have any unpaired electron. So this is the only case wherein the central metal ion, it has got the unpaired electron. And wherever you see unpaired electrons, DD transitions are going to happen. And due to the DD transitions, the species is going to be colored as well. That's something which all of you would be already knowing. Perfect. So these were some short 10 concepts which are frequently asked every year in your NEET. So have an eye on these concepts, my dear students. Anything can be asked from these particular 10 concepts which I've given you in a short interval of time. Take care. God bless you all and love you all. Bye-bye.